Greetings. This session, this video session, will be dealing with the problems that were set by the South African Mathematics Foundation, whose website address is www.samf.ac.za in the year 2022. It is the paper that was set in the National Mathematics Olympiad for the seniors. It means grades 10 to 12, the second round of that competition. So with those few introductory remarks, we will go straight to paper in question. Right, the first one is very simple. All it does is just testing board mass. And you will see division and multiplication. The problem here is that if you divide first and then multiply, or if you multiply first and then divide, you will get two different answers. And the question is, which one should you choose? And there is a general rule called board mass, which says that as a rule, division must precede multiplication. So therefore you divide first, 8 divided by 2, then multiplication so it's 3 minus 5, 4 times 7 is 28, 26. Okay, that's a very simple start. So not much mathematics. It's just testing to see whether you remember this rule. I always give the answers which are prepared beforehand, largely for myself to check, but at the same time, it's also for you so you can see. Sometimes there may be a different solution to the one I give. Well, it depends what solution I remember when I am talking. Okay, so let's get on to the next question. How many of the integers from 1 to 100 are not multiples of 6? Okay, it's easier to identify the multiples of 6, which goes all the way up to 96, which is 6 times 16. This is 1 times 6. So you will start from 1 times 6, 2 times 6, all the way times 16 times 6. There are 16 multiples. This is from 1 to 100. 6 in the set. Therefore, the set has got 100 elements. So the number of are the non-multiples. And the number is the number Okay, so the answer is 84. As you can see, this is also the answer that has been prepared in advance. We get on to question 3. A snowman is built by stacking three spheres, as we see, aligned vertically. Okay, sorry about that. The spheres have radii 10, 20, and 30. How tall is the snowman from top to bottom? Well, this is very easy. If the radii are 10, this is the the the, the snowman is this height here. And you can see it's equal to the sum of the three diameters. So the radii are 10, 20, and 30, and therefore the diameters are 20, 40, and 60. So you can add up all the three, and the answer is quite obvious. Or otherwise, you simply add these three and multiply by 2. That's 60. The answer is 120 centimeters, which is 1.2 meters. Okay, that's straightforward. As you can see, the answer is 1.2 meters. Question 4 is the next one. Emilia writes down the numbers 5, x, and 9. Valentine calculates the average of each pair of these numbers. So you got the average of each pair. Okay, the pairs are 5, 5, and 6. To find the average, you add the 2 and divide by 2. The first and second, first and third, and second and third. The only three pairs. And these averages are equal to 7, 10, and 12. 5 plus 9 over 2 is 7. So that takes care of that. So we have to see which of these 5 plus x over 2 is one of these. Well, obviously it's smaller than this, and the one that is smaller than the smallest one here is 5 plus x on the left-hand side, must be equal to the smallest one on the right-hand side. Multiply by 2, 5 plus x is equal to 20, and x is 15. Okay, so the answer is 15. All right, that's the answer that I had calculated some time ago. So let's look at the next question, question 5. How many factors does the number 600 have? Okay, this is probably, if you haven't seen this before, the number of factors. The number of factors of any number of, let's take 36, for example. How do you do it? You take 36, you factorize it, 4 times 9, and then write it as powers of prime numbers. So 4, if you factorize it further, you can always write every number as a product of prime numbers. If you collect them together, you can get the powers. And the number of factors is, you take the exponents, add 1 to each one of them, is add 1 to each of the exponents and multiply them out, and that gives you a number of factors, right? So you can actually check it out with 36. The factors are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and then you have 6. You don't count 6 twice. And after that, you only go up to the square root because all the other ones, the larger ones, are also included in this. And you count this, you get 2, 4, 6, 8, 9, and that is the answer. So that is how you do this. You factorize, take the exponents of the powers, add 1 to each one of them, and multiply the answers. So this is 6 times 100. 6 is 2 times 3. 100 is 10 times 10. You have to write it as prime numbers, prime factors. 2 times 3. 10 can still be factorized. And now, in this factorization, you cannot be factorized any further. You see you've got 3 2's, which makes it 2 cubed, and 1 3, and you got 2 5's. So this is the factorization into powers of primes. These are prime numbers, right? So therefore, the number of factors of 600 equals, you take the exponents, 3, the exponent here is 1, 3 to the 1, and increase it by 1. I'm sorry. The first exponent, which is 3, if you increase it by 1, you get 4. The second exponent is 1 times, you have to multiply this, 1 plus 1, and the third exponent is 2. 2 plus 1 is 3. Multiply them, and that gives you the number of factors. So if you write down all the factors, you'll see there are 24 of them, quite a few factors. And this is the answer. Okay, I'm going quite briskly through these first few because they are quite easy. Hardly second round senior questions, but they usually have a few warm-up questions to give people confidence. They don't want anybody to get 0. Okay, so here we go. Let's get on to the next. Okay, you can see it's 24, and I give you the general formula for it. So you can have a look at that if you didn't understand what I said earlier on. Okay, that takes us to question 6. Snappy the dog is ill and must have 1 blue pill and 2 pink pills. So the dog has 1B plus 2, maybe I better not write and, plus and 2 pink for 10 consecutive days. Okay, so each day it has this amount. A blue pill costs 1 rand more than a pink pill. So the pink pill price is not given. So let's give a name to the price of the pink pill. Let X be the cost of the pink pill. All right, so in each day, the pink pill costs X for 1. So let's take 2. So it's 2X. That's the cost of the pink pills. But the blue pill costs 1 rand more. So there's only 1 blue pill. The cost of the pink pill is X. So the cost of the blue pill is X plus 1. You only take 1 of that. So the cost for each day is x plus 1 for the single blue pill and 2x for the pink pills. Now, the total amount for the pills is 520 rands. Now, this is the cost for each day. So therefore, for 10 days, it will be, the total cost will be that amount times 10. And it's given that this is 520. All right, so they ask you, what is the cost of the blue and the pink pill together, right? Blue plus pink. We said the pink pill is X and the blue pill is one more. And so that's the answer, but we need to calculate X and it comes from here. So something, this times 10 is 52. In the bracket, you got 3x plus 1, 2x plus x. And then if you divide on both sides by 10, you get 52. 3x plus 1 is 52. 3x is 51. So x is 17. So that tells you that the value of x is 17. And we've worked out 17 times 2 plus 1 is what the blue and the pink will cost together. And the units, you should say, is rands. So the blue and the pink pill together cost 35 rands. You have to do it systematically. Right? Look at all the information and build up the equations and solve. Make sure you find out what the goal is. And the goal is to find the blue and the pink, translate that into symbols, and then you know exactly where you are going. All right, so according to me, the answer is 35. Let's just check to see whether this is indeed the answer. Question 6. Yeah, okay, you see at the bottom of this page, it's 35. Okay, let's get on to the next question. Lines A, B, and D, E are parallel. These two lines are parallel, and the angle CDE is 40 degrees. Okay, it's not stated there. Let's just show 40 degrees. And the question is, what is X? The writing is rather small, but this X here represents this angle. All right, this kind of question occurs very frequently. The trick is through that middle, so the point in between, you draw one more parallel line. So there is a construction, right? Construction. And normally, things which are not in the diagram are put it in red. Those are the constructions. So you draw a parallel line to this. And by the way, it said that angle C is 90 degrees. They should have said it here. But the symbol for 90 degrees was there, which are blocked out, the right angled. And you can see that right angle there, so that's given as 90 degrees. So once you draw a third line which is parallel, it will be parallel to both the given lines. So then it becomes easy because this is alternate angles, 40, 40. The whole thing is 90. So this must be 50. and these two are co-interior angles. The co-interior angles, they add up to 180 degrees. So x must be 130 degrees. So that's the answer to that question. X is 130. As you can see at the end of this, I say that x is 130. All right, question 8. In the sketch, ABGHI is a regular pentagon. Pentagon, I'm not sure how you say it. We'll call it pentagon. A regular pentagon. That means it is a quadrilateral with 5 sides, because that's what a pentagon is. And regular means all the sides and the angles are equal. So remember, in a regular picture, all the sides and the angles of this polygon are equal. That's a regular polygon. This pentagon has got 5 sides. So they ask you what the angle, there's some angle which you have to find. The angle is indicated here, it's a small little angle, IAF. So sort of there's I, there's A, there's F, there's IAF. It's a tiny little angle there. So that's the question. Now, in any polygon, it's easy to calculate angles of polygons, because the main thing is that the sum of the exterior angles in any polygon it's always the same. It's 360 degrees. See? No matter what the polygon is. If I take this particular one, let me just say something about that. The exterior angles means you take each side, extend it, and then from here you go on and extend the next one. Must be extended in the same direction. Here, extend that. From here, extend that. From here, you extend that. From here, you extend that. And these new angles, which are formed, are called the exterior angles. So you can see in this 5-sided figure, I've got 5 exterior angles. They are these new ones which have been created. Right? And the sum is 360 degrees. If you remember that, then you can answer most of these questions on polygons. Right? Because here, in a regular polygon, all the interior angles are equal. So all these exterior angles are the same. So you got 5 numbers, all of which are the same. So each exterior angle is 360 divided by 5. The reason for that is they're all equal. Can't say this in general. So all the exterior angles are 172 degrees, and therefore the interior angles, which are all equal, are each 180 minus 72, and that's 108 degrees. So that's how you calculate the interior angles of any regular polygon. Oh, wait a minute. This outside one is 60. I mean, it's a 6-sided one. That's the hexagon. So I have to divide by 6. Sorry. The 6 angles. 1, 2, 3, 4, 5, 6. So you divide by 6. So it's not 72, but 60. And the interior angles are therefore 60. 60 degrees, 180 minus 60 is 120 degrees. So this angle here is 120 degrees. The full angle. And I'm focusing my attention on this. So this angle here, let's call it X. X is the difference between this full angle minus this other angle. The interior angle is X is equal to the interior angle of the hexagon, which we just calculated to be 120. And in error, I calculated the interior angle of the pentagon, so I'm going to use that fact. It's 108 degrees. So that minus the interior there is the X which we're looking for. That's 12 degrees. All right. So it's just a matter of knowing that the angle that you're looking for is that angle minus that angle. So it's the interior angle of the regular pentagon, regular hexagon, minus the interior angle of the regular pentagon. And those two can be calculated as I showed. And the answer that you come to is 12. So there you have it. You can see the final answer there is 12. The next question is, two squares are drawn inside a rectangle, as shown. If each square has area 11 square units, I'm sorry, 121. I'm thinking ahead. The area is 121. So therefore, the sides will have to be 11. So these are 11. What is the area of the entire rectangle? Now, there are two ways of doing this. I'll do the long way first. So the area of the rectangle is length times breadth, but observe that the length is this. And the breadth is from here to here. Okay, let's make that like that. Okay, so the length of the rectangle is twice the diagonal. That diagonal plus that diagonal. Let's call it D. Let's call this, let's call that D. So the length is twice D, and the breadth is just D. And therefore the area is 2D squared. But D squared is 11 squared plus 11 squared. Because it's a right angle triangle. See, in a square now, I'm using various properties of a square, that the diagonals of a square are equal. The diagonals of a square cut each other at right angles. Right? This doesn't happen generally, but in a square, you all have a lot of nice things, right? And so the angles of a square, 90 degrees, and so on. So you've got the sides are 11 and 11. So this is 11 squared plus 11 squared using Pythagoras. And that gives you so it's 121 plus 121 is 242. That's the area of the rectangle. There's your D that you're looking for. 11, 11. This is 242 times 2, which gives you 484. 121 plus 121 is 242. Right. So the area is 484. I told you I will do the long way first. And that is the way you do this. You have to calculate the length and the breadth of the rectangle, and the length. Don't put the length there. Look at the length here. So then you can see it easily. And then to make the calculation simple, you know the same number is repeating several times. So give a name to it, D. That is D. That is also D. And then put the algebra and you get the formula in terms of D. Then you calculate D. See, if you do calculate D beforehand, it can become a little bit nasty, the calculations. So often in problem solving, it's better to give symbols to clumsy figures. And then you do all the calculations, and then you come back and replace that symbol with the clumsy figure, and you'll see a lot of things work out very nicely. All right. It saves you a lot of terrible calculations, because you're not allowed to use the calculator in all these problems. So remember, the answer was 484. Now, another way of doing it is I can merge this. You see, these two, the A's, you can put them together, cut this thing out, and put it there like that. Right? And these here, we call them B. 4 of them are the same. And if you put these 4 together, cut these 3 corners out and put them here, and then you will have the total area now. This is all your B's are here. Right? And these 2 A's are there. So you have this square plus that square plus that square plus that square. So the answer is, if you cut and paste, it will be 4 times the area of the square, which is 121. That's 484. See, a little bit of thought. You don't even have to calculate the side of the square. You just look at it and you say, well, wait a minute, I can cut these pieces out and put them together, and I can get a very much nicer picture. This happens quite often. Cutting and pasting will help you to solve problems. So just remember, that's an interesting strategy. So in this case here, these 2 together make 1 square, and these 4 quarters make another square. So that makes 2 more squares to the given square, 2 squares. That's how you get 4 squares altogether. All right, so that's the other strategy. Well, you see, I didn't have the short method. In fact, I used the worst one. I didn't call this thing D or anything like that, and I got all these square root signs and so on. So my solution is not the best solution. The one that I just told you is very much better. Okay. Get on to question 10. The distance from Heidelberg to Pietermaritzburg along the N3 highway is 450 kilometers. Okay, so you got 2 towns here. You don't really have to know much about those towns. You can draw a little diagram. And at one end, you put H for Heidelberg, and the other one is Peter Mansberg. Very often, I don't read the whole problem. I gather the information in the form of a picture or an equation or something like that, and then carry on. Because this, you don't want to take on all the information simultaneously because it can be very overwhelming and you wouldn't understand what the heck is going on. So you know this distance here is 450. I wouldn't put kilometers, I'll put kilometers at the end. Two cars head towards each other. Okay, so one leaves Heidelberg, the other leaves Peter Mansberg. So I presume, oh, they leave at the same time. All right, so both of them leave at 8 o'clock. All right. And the speed of the first car, the Heidelberg one, is 40 kilometers per hour, and the other one is 50 kilometers per hour. In how many hours will the cars meet? All right, they meet somewhere. They probably will meet closer here because this guy is traveling faster. But this is the meeting point. Let's call it M. Now, the important thing is that they meet at the same time. They left at the same time, and they meet at the same time. So both travel the same number of hours. Let's call it T. That's what they're asking for. In how many hours will the cars meet? So this car traveled for T hours, and this car traveled for T hours also. Now this picture here will give you an equation. Because the speed here is 40 kilometers in 1 hour, so this distance here in T hours, it has to be 40 T. Because in 1 hour it's 40, and 2 hours is 80. In T hours it will be 40 times T. And the same thing with this. So these two have traveled. This has traveled 40 T, this has traveled 50 T. And you know that together, it's the distance between the two towns. 90 T is equal to 450. So T is equal to 5 hours. So you must put down the units. So this is in how many hours? This is the answer. Because we said T is the number of hours when they meet. In the diagram, you can see it. Okay. Now, usually they give you a distance time, and sometimes it can be very, very complicated. But this is a very easy one, actually. If people are interested in using formulae, then the formula is distance, a very important formula. I didn't use it, but distance is always equal to speed times time. So if you did that, you got time, you got the speed. Speed times time is the distance, as you can see. The same thing with this distance here is speed times time. It becomes 50t. All right. But I said in 1 hour it travels. That's much better to understand it. 40 kilometers per hour means in 1 hour it covers 40 kilometers. Therefore, in t hours it will cover 40t. And that tells you that you need to multiply these two numbers, which is speed times time. Okay, so we said the answer is 5 hours. And as you can see, it's just exactly the same thing. And we land with the same answer. Okay, so let's get on to the next problem. This is question 11. Sardines are sold in cylindrical cans. 2 tins or the diameters increased by 25% are designed. Okay, so you got 1 tin, the diameter is increased by 20%. The diameter is from here to here. And the other one, the diameter, the cylinders, so you have a circular base. Cylinders have always got a circular base. Now, so this thing here is 25% more than that. So let's call this diameter D. If this diameter is D, this thing here is 25% more. Now, 25% more, that's 125%. Percentages, if you convert to fractions, is 125 over 100. And when you simplify, this 25 goes into this 5 times. So in other words, this is D, this is 5 over 4 times D. Right? It's 25% more. Now, they say, by what percentage should the height of the newtons, so you have a height this height is a little smaller. So let's call this height here H. By what percentage should the height of the newtons be decreased? Okay, we don't know what this is. Like here, we knew what the new diameter was. We don't know. So this is really the question. What must you decrease this by to keep the volume of the tins to be the same? Right. So obviously you have to use the formula for the volume of a cylinder. Now in all these pictures, whether you got a cylinder, or you got a triangular base, or you got a square base, that's like a cube now. A circular base, triangular base. The volume is always equal to area of base times height. Remember that. As long as it's a vertical thing, it's like a cube, vertical. This is a vertical thing that's standing on this bottom. So you can remember this one formula for all these. Area of base times the height. So in the cylinder, the area of the base, now let's see what the volume here is. Now, the base, the area of the base is a circle, and the area of the area of a circle, sorry, is pi r squared. That's a nice formula. So the base area is pi. Now, I don't have r, I've got diameter, right? But r is actually equal to half the diameter. So we'll put d over 2. That's your r. That's your pi r squared. That's the area of the base times height. Now here, the volume here is, again, but now the diameter is 5 over 4. So it's half of 5. We can make that 5d over 4. 5 over 4 times d. that you square it, and the height is h. Now these two are equal. They say that these two are equal to keep the volumes of the terms to be the same. So let me just make that equation. Let's simplify this. What do you get? That volume is pi, numerator is d squared h over 4, and these two are equal. So numerator now is, the numerator here is this is 5 over 8, 5d over 8. You're squaring that. Okay, so the numerator is this is being squared. Is 5d all squared, which is 25d squared. Well, there's a pi times the numerator squared over 2 4 is 8, that's 64, times h. So now you can cancel. The pi is cancelled, the d squared cancels, and you have h let's make h the subject. So you have to multiply by 4 times 25, right, over 64 times capital H. Okay, so this is 100 over 64. So you can see that to raise the percentage to 100, okay, you have to think about this. They ask you that the oh, what happened here? Sorry, this h here should have been smaller than h, but this is bigger. Oh, okay. You have to increase this. So capital H is actually equal to 64 over 100 times h. You should multiply on both sides, and that is 64%. Of small h, sorry. Right? H on this side, you got 100 over 64 of small h. So the height has to be decreased by what percentage? From 100, it comes down to 64. Therefore, the answer is 100 minus 64. So you have to find out what the connection is between the small h and the capital H. And if you use the fact that these two volumes are equal, then the mathematics kicks in, cancel off the like terms, and find small h in terms of h, or capital H in terms of h. That's what you needed. You needed to know what is the new height. The new height, if you make it the subject of the formula, you see it's 64 over 100, which is 64%. So the new height is smaller than the original one, and it's 64% of it, so it has to be decreased by 36%. All right, so let's just get on to the so you can see 36. And oh, I've got some other way of calculating this thing, which I think is really atrocious. That looks far more complicated than the one that I chose. You see, Usually there are easy ways of solving the problem, but you have to recognize the easy way. Now, I'm too much of a mathematician. I put symbols all over the place and make life complicated. Anyway, fortunately, I've matured since I last wrote these solutions, which is some time ago. Okay, let's get on to the next problem. Question 12. Last Thursday, each learner in Ms. Molopez's class brought either an apple or a banana. Oh, okay. Now, to draw a diagram for this, I'm not very good at drawing diagrams. So you got each learner brought an apple, or that's not bad, and a banana, but, or an orange. Either an apple or a banana or an orange to school. So each learner brought any one of these three things. In total, 20% of the learners brought an apple. So we don't know how many learners there are. So you got how many students were in the class? So that's the question now. So let's give a name to that. Let x be equal to the number of students. That's what you need to calculate. So we're going to try to find an equation involving x using the information that is given. So it is said that 20% of the learners brought an apple. So the apple people were 20% is 1/5. So you have to divide the number of learners by 5 to get 20%, right? And you've got 35% brought a banana. Okay, that's not so easy, but it's 35 over 100 times x. That's 35%. If 9 learners bought oranges, so this equals 9, how many students were in the class? Okay, so you know that everyone brought, so the total number of students in the class is x over 5, the number of people who bought apples. 35 over 100, I can cancel the 5s. 5 goes into 35, 5 goes into 100. And then plus 9. These are the 9 people who brought the oranges. And that is equal to x, because that's the total number of students in the class. Right. So now you've got an equation involving x. I don't like fractions, so let's multiply right throughout by the common denominator. The common denominator is 20, as you can see. So multiply right throughout by 20. So multiply. Looks like an x. Multiply this by 20. 5 goes in 20 4 times. 4x. Multiply this by 20. 7x. 20 cancels. 20 times this is 180. Multiply this by 20. 20x. So you have 11x here, 180. Bring all the x's to one side. 20x minus 11x is 9x. Oh, that's a nice answer. 9x is 180, so x must be 20. This is equal to the number of learners in the class, pupils. Okay. In days gone by, we used to call them pupils. But then everybody became so concerned about languages. They said that sometimes there are adults in the class and you can't call them pupils, it's too degrading. So let's call them learners. If you want to know the history of the word learners. Okay, so you got 20. That's x is the number of students. So you see, it's all a matter of reading your question and going in systematically and get your equation, right? So if you do it like this now, you will see that many of these problems are quite easy, right? Don't read the whole thing. So, oh, I don't know how to do this. It's You must do it step by step and unravel the mysteries inside a problem. Okay, so we saw the answer was 20. Check my answer. Oh, there it is. I called the number of learners n rather than x. You come to the same answer. Okay, so we go on to question 13. All right. So question 13, it reads as, for what value of p greater than 0 will the triangle with vertices 0, 0, p0, and 22, 22 have an area of 22 squared? Okay. In this case, I've read the entire question. So you've got the coordinates here. So let's draw this coordinate system. The vertices of the triangle are 0, 0. So the x equals 0, y equals 0. So this is one vertex. The other one is p0. So in other words, the y coordinate is 0. So the y coordinates are 0 along the x-axis. So there's a point here, p0. Oh, p0 means that this length here is p. Let's put it down straight away. Right, it's along the x-axis. And then 22, 22. So the x coordinate and the y coordinate are the same. So let's just put somewhere here. Okay, now what does this mean? It means that the y coordinate is 22 and the x coordinate is also 22. But what's important is that the y coordinate is 22. Now to work out the y coordinate, from that point, you have to draw a perpendicular line. And the length of that line is 22. And from here to here, I prefer from the origin to this point, that's also 22. Okay, now they want to know the area is 22 squared. The area of this triangle, because it's got three vertices now. So there is a triangle. So let's draw the triangle. And the area of this triangle is 22 squared. Now, in this figure, you can see what the area is going to be quickly. The area is actually equal to half base. The base is P. Oh, what happened? Everything is being smudged out. Evidently I did something. Oh, plus. Oh, fortunately, it doesn't disappear. I seem to have solved the problem very quickly. So the area of the triangle, the formula for the area of a triangle is half base, and the base is P, times the height. Now, you know the height, diagram you can see, I got that as 22 because that's the y coordinate of this point. And they say the area is 22 squared. Okay, that's very nice because then you can cancel the 22s. So you get P over 2 spot here. Take off one of these 22s. And you have 22 there. So P is equal to 44. They ask you for what value of P is this. They have to say P greater than 0 because you could have drawn it on the other side. But even there, it'll be half base times height. But in that case, P would have been negative. Right, so there are two possibilities for this. But I think 99% of the students would have done it like this. But just to be on the correct side, they have to say that P is positive. Okay, so my answer is 44. And to check, there it is. Okay. Oh, I made that 22 exactly over the middle, which I shouldn't have done. No, we have no idea where it is. Okay. All right. So the next problem will be question 14. They say 3 of the first 5 positive integers are chosen at random. Okay, let's focus on that. What is the meaning of this? Now, the first 5 positive integers are 1, 2, 3, 4, 5. Okay. Now, 3 of them are chosen at random. So you have lots of possibilities. You got 1, 2, 3. I'm going to put them next to, this doesn't mean 123. I'm just going to put them next to each other. 1, 2, 3, 1, 2, 4, 1, 2, 5. Because starting with 1, you can put 2, 2, 3, 4, 2, 3, 5. And then you got starting with 3, 3, 4. Sorry, let's do it again. I need to show you how to collect together all these things. Let them start with 1. So you can start with 1. You have 1, 2, 1, 3, 1, 4, 1, 5. Right? And then you can make, and this becomes 3. Let's put them in increasing order. So 1, 3, 1, 2, 3, 1, 3, 4. Okay, starts with 1, 2. You'll have 1, 2, 3, 1, 2, 4, 1, 2, 5. All right. Now I'm going to take 1, 3, 4. I'm not going to put a 2 in because I've already got the 2s. I've got 1, 3, 4, 1, 3, 5, and 1, 4, 5. Okay, so that takes care of all those which start with 1, 1, 3. 1, 4, 5 is already included. So now let's start with 2. So you have start with 2, 3. So you have 2, 3, 4, 2, 3, 5. Right? Starting with 2, you can still have 2, 4, 5. And then you have 3, 4, 5. So you got so somewhere I yeah, see I repeated 1, 2, 4 there. 1, 2, 3, 1, 2, 4, 1, 2, 5. So you got 10 altogether. It's much easier to, instead of counting all these, instead of counting three of the integers, ask yourself, what are you leaving out? So you can leave out, so that's easier to work out. Leave out 1, 2, leave out 1, 3, leave out 1, 4, leave out 1, 5, and then you leave out 2, 3, leave out 2, 4, 2, 5, and then you leave out 3, 4, 3, 5, and then 4, 5. Starting with 1, 2, 3, 4, and you will see you got 10 again. And then that will tell you what the other parts are. This 1, 2, that means I'm talking about 3, 4, 5. Right? I've left out 1, 2 in that one. If I take 2, 4, then I'm leaving out 1, 3, 5. So instead of counting all these, you count these. That's very much easier. See? So the point is that there are 10 such choices of 3. There are 10 such choices. I haven't even read the rest of the question. I just asked myself, they are chosen. So what are they? Then arrange in increasing order. Okay, I've done that here. Okay. And the question is the probability that the 3 chosen numbers are consecutive. All right, which are the consecutive ones? 1, 2, 3. None of that. Let's put that in square brackets. Yeah, start with 2, 2, 3, 4, and 3, 4, 5. Those are the only consecutive numbers. The one that starts with 1, this one starts with 2, the one that starts with 3. So there are only 3 consecutive numbers. The probability of the 3 chosen numbers are consecutive, the probability you can see is 3 out of 10. Because there are 10 possible ways, and only 3 of them have satisfied this business of being consecutive. So the probability is 3 over 2, and it's P over Q. Oh, this is then, P over Q is supposed to be somewhere. The probability the 3 chosen numbers are consecutive is, this should have been P over Q here. This thing jumped in lowest terms. So P is 3. This is lowest terms, as you can see. We can't simplify this further. So P is equal to 3, Q is equal to 4. So P plus Q is equal to 13. They ask you find the value of P plus Q. All right. So in this case, I actually wrote down the whole lot. But better is there's a very useful formula which I will tell you. And please try to remember this formula. The number of ways of choosing two objects. We'll call them objects. Could be cows, whatever. In this case, they are the first five positive integers. Two objects from n objects. That's why it becomes a formula, because no matter what n is, you can write it down straight away, is n into n minus 1 over 2. Yeah? Now, just remember that my answer was 13. I need more space here. The same thing, the number of ways of choosing three objects. Just change the 2 to 3 from n objects. Leave n same. Is n into n minus 1 times n minus 2. You have three factors. 1 times 2 times 3. You've got three factors there. So you can put on three objects. You can put on at the bottom, you can put 1, 2, 3. At the top, you start from n and you reduce. Why do I say that? Because you can have the same formula. Instead of three objects, you have r objects. Very general formula. From n objects is, formula becomes a little bit complicated, but it's a formula. If you don't have it, it takes very much longer to work it out. The denominator, as in the case of, this is 1 times 2 here. This is 1 times 2 times 3. So at the denominator, we have 1 times 2 times 3, going all the way up to r objects. And at the top, you start from n, and you keep coming down, but you stop as soon as you have r factors. The same number, you got 1, 2, 3, 1, 2, 3. See, it's very, very useful formula. So here, if you say the number of ways of choosing three objects from 5, so you start, n is 5. So three objects, I'll already give you a formula for that. So it's going to be 5. Okay. It's 1 times 2 times 3. Three objects. 5 times 4 times 3. 3 cancels. 2 goes into 4 2 times. 5 times 2 is 10. Right. Straight away, you can write down the number of, without actually listing down 1, 2, 3, 1, 2, 4, 1, 4, 5, and all that. So you can write it down straight away. And you will see that, as I said, it's the same as the way, as the number of ways of choosing two objects, because two objects would have been 1 times 2, 5 times 4. It gives you the same thing, right? And I told you why these two are the same. Instead of counting the three sets, count what's left out, and you'll come to the same thing. So all this is very interesting. It comes under the guise of probability. All right. So I spent a little bit of time on that to explain some more deeper results regarding this. Okay, let's go on to, let's just make sure that our answer is 13. Or you can see P plus Q is 13. And okay, I've explained this. Again, I got 5 times 4 over 2 and so on. So I do use that formula, right, which I just mentioned. Okay, let's get on to the next question, which is question 15. This paper has got 25 questions. All the second round papers have got 25 questions. Okay, now question 15. This becomes a little bit difficult now, right? Finished with the relatively easy questions. You got a drawer in a darkened room contains a large number of socks of 4 different colors. So this room has got a large number. Well, evidently this should be in a box. Why? They should say in a drawer. Okay. Forgive me. So this drawer has got a large number of socks. So let's just put the drawer down somewhere. There's it. It's got of 4 different colors. So you got a black. Oh, sorry. So you got maybe a black socks, red socks. I don't want to put white socks here because nobody will see it. Blue socks. Or you could have had maybe brown socks. So you got 4 different colors and they're all over the place. Right. A child selects socks from the drawer, but is unable to see the color of the socks drawn. Okay. What is the smallest number of socks that must be selected to guarantee that the selection contains at least 10 pairs? Oh, this child has got all the time in the world. So you want 10 pairs. Right? Now, to get 10 pairs, you need to have at least 20 socks. But you could have 20 all black, all brown at least. That'll give you 10 pairs. So every time you have 2 of the same color, you got a pair. So you need to have at least 20 socks, which you must draw. They need not be the same color. You could have had 4 brown and maybe 2 red and maybe 6 black. Right? And this way you'll have 2, 3, 6 pairs. Okay, so it's a little bit complicated because you have different colors, you see. But okay, let's start. At the starting point, you need to have at least 20 socks. Now, this is a very nice problem. It's very logical. And I'm going to go through this problem in a very systematic way. There's no formula or anything like that. For that, it's just pure logic. Okay, now you have to listen very carefully to what what I'm saying. Okay, now there's this child. This child has needs at least 20 socks, right? So suppose the child has picked 19 socks. Let's cut the child out of the picture. We'll just say, suppose 19 socks have been picked. They wanted to know what is the least number of socks you must pick. So let n be the least number. But it must guarantee that you got 10 socks, 10 pairs. So 19 would certainly not give you 10 pairs. So n is greater than 19. Right. Now, The child can pick up one more and get 10 pairs, but that's not a guarantee, right? So how can you ensure no matter how these 19 socks are picked, no matter how many you have of each, how can you be sure that after a certain number you will always have 10 pairs? So that's the challenge. Okay, so we don't know how many of each you've got. So we will say that A, B, even the colors were not given. So A, B, C, and D, B, the number of socks picked of each color. Of each of the 4 colors. All right, so you got A of one color, B of another color, and so on and so forth. Right? Now, for a start, you know that A plus B plus C plus D is 19. And now you start thinking. To count pairs, you have to pick 2 of 1 to get a pair. Right? Now, A is either even or odd. If A is even, then, so suppose A is 6, then that guarantees 3 pairs. Right? And if A is odd, say if A is 9, that guarantees 4 pairs because you got 9 of one color, and then but there's one odd one, and the other 8 you can make 4 pairs. So it all depends on whether A is even or odd. There are certain things you can count the number of pairs that you have depending on whether A is even or odd. Now, okay, so it's all about even and odd values for these. You got 4 numbers which add up to 19. So how many are even and how many are odd? But this is an odd number. So you can't have, for instance, you can't have all even. Okay, let's count the number of odds. 0 odds. You could have 1 odd. 2 odds. 3 odds. Or 4 odd. I'm talking about in these numbers here. Right? A, B, C, D. Right? Can there be 0 odd numbers here? If there are 0 odd numbers, all of them are even, and the sum of 4 even is 19. So this is out. That's not possible. In fact, you can't have 2 odds because then the other 2 will have to be evens, and 2 odds will add up to an even. So you'll have even plus even plus even. So you can't have 2 odds, or you can't have 4 odds. 4 odds also will give you an even number. So you see, just from this equation, you can make this logical conclusion that there is either 1 odd or 3 odds. These are the only possibilities. Okay. Now, take the 1 odd case. So 3 of them are even in this case. So let's call those evens B. We don't know which ones are even, but we can call it, because it's even, it's twice something. We'll call it 2P, 2Q, 2R, and then the one is odd. right? The other numbers look like this, and the odd number is, say, 2s plus 1. So to get three odds, or one odd at least, you have this situation. If there are three odds, we can just say, make it 2p plus 1, 2q plus 1, 3r plus 1, three odds, and the last one will be even. Okay, now these represents, this is your ABCD. I'm just rewriting those four numbers in terms of odds and evens, right? And now I know, oh yeah, so in this case here, when you add these four numbers, you're going to get 19 because it's the same set. So if you add those four and take the 2 out, you got 2 into p plus q plus r plus s plus 1. Adding all these, you get 19. And here, you got 2 into p, this is s here. This is 2 into, sorry, let me just, this is quite a crucial point here, and I'm squeezing all this here. Let's write this in properly. So the first one, let's take the first one and analyze it. Right, in this case here, I have that adding all these four numbers is the same as adding those four numbers, but we know that is 19. So if you take out the 2, and here you have the p plus q plus r plus s. Is 19 minus 1, 18, so it's 9. Now watch. The number of pairs, this is 2p, right? So you can take p, this gives you p pairs, q pairs, r pairs, and this one here has got one more than an even number, so you can still extract s pairs out of it. So the number of pairs is p plus q plus r plus s. So in this first case, the number of pairs is 9. This gives you 9 pairs. Almost there. We want to get 10 pairs. And in the second case, I got 3 odd, and that's the story there. And this time when you count these four numbers, this is 2r plus 1. Again, you have 2 into p plus q plus r plus s. This is the number of pairs, as we saw. But now you have to add 3 here. Right? These 3 ones, and you get 19. And this time, you got 19 minus 3 is 16. So p plus q plus r plus s gives you 8. So Let's just summarize what's happening here. So in this first case, we saw that we already have 9 pairs. In this case, in the second case, you have 8 pairs, because we saw the P plus Q plus R plus S is 8. All right, now the question is, from 19, now you already got 19, how many more must you take to guarantee that you are going to get one more pair? See? So, in the case of the one odd, how many more must you take to guarantee that you get one more pair? Now, you have to think carefully about this. Right? So, the worst case, you have to think the worst possible case, right? Because you want to guarantee, you see. Worst possible case is if you picked up one from here, that doesn't give you a new pair. You could have picked up one from here, right? 1, 1, 1. There's already 3, and you still got no pair. So you can pick up 3 here, but if you pick, then the last possibility is this one. But the moment you pick this one, you got a new pair. This loose one can join up with the one that you picked to get you a new pair. So you have to pick at least 4, right? You have to pick at least 4 more to land up with when you got 9 pairs, right? So in the case of one odd, n is equal to 23. This is the smallest number that you have to pick up to guarantee 10 pairs, right? It has to be 19 plus 4, right? In the case of 3 odd, what happens here? In this case, you need 2 more pairs, right? So if you pick the first one, in the worst possible case, you have this two Q plus 1. Okay, I'm not going to go into detail with this. The point is that even in this case, you have to pick 4 more to guarantee, right? Okay, if you picked a P, then you got at least 1, right? So that gives you 9 pairs. If you pick this one here, it gives you 9 pairs. If you pick this, you got 9 pairs. But when you pick this, you don't have 9 pairs. Right? Now you got 4 odd ones. Right? Then you have to pick. In this case here, yeah. So you got 9. Now you have to from the remaining ones, you have to argue how can you guarantee that you are going to get 1 more pair from those. So just argue it out. It's very similar to what I've been saying. But again, you will have 23. Maybe you'll get less than 23. I don't know. But it's the least number will again be, no, you will get 23. I checked it out. So even in this case too, you get n equals 23. I think I've written it out in detail, so you can see the argument. All right, so the answer to this question is, I need to pick up 23 socks to guarantee 10 pairs, right? It's a very logical argument. I hope you read this thing very carefully and try to understand it, because it's non-routine and it's no equation, nothing. It's pure arguments and pure logic. Okay, so let me just clear all those drawings and show you the actual solution. So yeah, you can see I argue the whole thing out. The one that I tried not to try to avoid is this one here, where you got 3 odd and 1 even, right? And you can check it out. But we're just saying the second 2 will suffice. Oh, I see. So that will make 21. 19 plus 2. If you take any 2, yeah, it seems to me you have to, 3 will, you could have picked the first one to be that. But this, yeah, but that doesn't give you 9. You still have 8, the first one. But now, any 2, all are odd. You take any 2, after that, you will have. So the second one actually gives you 22 choices. But the minimum number is 23. The worst possible case is where you got 9 pairs. All right, so that takes care of that problem.